So here is an example of looking at a binomial distribution and how we solve this question. So x represents the number of times we are going to be successful for this particular experiment. So here in total we have 9 trials and the probability of success is 0.2. So let's just indicate that P is probability of success 0.2, N is the number of trials. We've got 9 trials. Out of those 9 trials, the probability of being successful for one of the trials is equal to 0.2. So what could this be? I mean, X could represent, for instance, the number of times we get 5 on a biased dice. So the number of times we get a 5 on a biased dice. And we're doing this experiment 9 times. And X represents the number of times we get 5 on that dice. As it's a biased dice, the probability of getting a 5 in this case could be 0.2. So suppose we go down that route, we need to make sure understand what X actually represents. It's the number of times we're going to get 5, not a probability, so not to be mixed up. So how many times could 5 come up if we're throwing this dice 9 times? It could come up 0 times, once, 2, ... all the way up to it could come up 9 times. And this is what the random variable X is. Now let's take a look at the first question. It's asking us to find the probability that X is less than or equal to 4. So I always start my question with this number line which I've just drawn here. And I'll put down the number 4 because I'm interested in that for this first bit, probability of X being less than or equal to 4. So we want the number 5 on the dice to come up 4 times or less. So it could come up 4 times, it could come up 3, 2, 1. So we're really interested in this bit here. The number here would be 5 obviously, and that's the right hand side. So I always split up my number line into those 2 sections, what we're interested in and what the other side is. And I usually draw a line going down the middle, and we'll explain why that is. So everything to the left hand side is looking at 0, 1, 2, 3 or 4. Now, if I wanted to find out the probability of X being less than or equal to 4, I could find out what they are individually and then add them up. Alternatively, I could use my binomial CD function on the calculator. The binomial CD function on the calculator gives us the probabilities up to and including whatever value of X we're looking at, starting from 0. It only does this left hand side. Likewise, we've got the data tables, the binomial cumulative distribution data tables at the back in our formula book, and they also give us the numbers from 0 up to and including a certain value of X. So this left hand side, which I've got here, I'll write down here LHS, and this is the right hand side RHS. Left hand side is what the calculator and the tables actually work out. So we must always do our calculations using calculator and table on the left hand side, and if we are interested in the right hand side, we could do then 1 minus the left hand side to get that. So since we are going to find the probability of X less than or equal to 4, we would go and type into our calculator binomial cumulative distribution, and it gives us the option to type in the following inputs. It asks us to write what value of X we're going up to and including, since it's a binomial CD. It tells us what to write down for the number of trials and what to use for the probability of success. And the output from the calculator for this binomial CD function will be what the probability of X less than or equal to whatever number we use here. Now since we're interested in everything less than or equal to 4, we're going to use 4 here. X is less than or equal to 4. So the answer that we get from the output, the calculator output, will be the probability of X being less than or equal to 4. The number of trials we're carrying out, well, there's 9 trials, and the probability of success given in the question is 0.2. So we can go and use this then on our calculator, and on calculator you can go to a menu, find number 7, which is distribution, and then scroll down, and it gives you an option to type in binomial CD and then choose variable. Put in the inputs as we've shown here. 4 for X, press equals. N is 9, press equals. Probability of success is 0.2, press equals, and it will then give you the answer for probability of X less than or equal to 4 coming out as 0.98 0, 4 to 4 significant figures. Okay, so that's the answer to the first bit there. Now let's go and take a look at how we would find out, suppose if we wanted to find out what the probability is for the second one, which is part B, probability of x less than 3. I'll do the same thing, okay? So I'll do the same thing, I'd start again, but certain things will change here. So now we're not interested in that, I'll take that off. My same number line holds, so I'll keep the same number line. I'm interested in the number 3, I'll put that in here. I'm interested in probability of x being less than 3 in this instance. Okay, so let's see what we have to change. Well, probability of x being less than 3 means we don't want 3, we want less than it. So we want this side. Put a vertical line here, and this would be the right hand side. Now you can see that we are going up to and including the number 2. The calculator, the binomial CD function, and the table goes up to and including the number. So although we're finding less than 3, we wouldn't put down 3 here, that would be wrong. Instead, what we need to do is we need to go up to and including the number it goes up to here, 2. Everything else remains the same. So what will we get as the output? The output will be probability of x being less than or equal to 2, which is exactly the same as the probability of x being less than 3. Okay, so probability of x less than or equal to 2, go into your calculator, and we would again go into the binomial CD function, choose variable, and change your x input this time to 2. Press equals 9 is for n, and 0.2 is the other one, so then this would get us an answer of 0. Just move that over a bit. Gives us 0.7382 to 4 significant figures. And this is also the same as probability of x is less than 3. Less than or equal to 2 is the same as less than 3 because we are looking at discrete random variable. We can't have anything between it's either 2 or 3 or less. Okay. So that's the same thing. So we've answered the second one. Let's go and take a look at how we would approach then the next bit, which is here, finding probability of x is greater than or equal to 2. Again, start off with my same number line. Don't need to write every single number. Obviously, sometimes you could have 0 to 40 successes, so we wouldn't write everything. That's why I've got the ... I'm only interested in the numbers that are mentioned here. So they mention now 2, so I'm not really interested in 4 or 5. You can just have ... there. Again, I'm going to rub out the things that we are not interested in, the things that we will be changing. So still a binomial CD. Let's see what we're after now. This time we're looking at x is greater than or equal to 2. Greater than or equal to 2 means it includes 2 and more. So we're interested in this side. So obviously what's on the left hand side is 0 up to and including 1. Again, I draw a line down here. So remember, although we are interested in the right hand side, this side here, and so I'm going to write down what I'm interested in here, greater than or equal to 2. Probability of x is greater than or equal to 2. My calculator doesn't work out the right hand side, nor does the cumulative distribution table. It only gives us the left hand side. We can only work with the left hand side. So I will write down what my left hand side equivalent is. So I'm using binomial CD still. I'll just make a note here, binomial CD. And since I want the right hand side, which is x is greater than or equal to 2, the side that I'm going to work with is probability of x less than or equal to 1, as you can see here, because it goes up to and including 1. So I'm going to use my calculator to work out the left hand side, from which then I can work out what the right hand side is. So what is the left hand side? It goes up to and including 1. N is still 9 trials. Probability of success is 0.2. It hasn't changed. So for these values, go and put that in. So we're going to put in x is equal to 1 in our calculator for binomial CD. N is equal to 9. Probability is still 0.2 for success. And this would give us an answer for the probability of x less than or equal to 1 coming out as 0.4362. Now remember, this is the probability for x is less than or equal to 1. So how do we find what we're interested in, which is the probability of x being greater than or equal to 2, i.e. what's on the other side? Well, we know all the probabilities add up to 1 for the whole distribution. So if probability of x less than or equal to 1 is 0.362, what's left on the right hand side, i.e. probability of x greater than or equal to 2, is equal to 1 minus the probability of x less than or equal to 1. 1 minus that value there, 0.4362. And if we work that out, 1 minus 0.4362 gives us 0.5638. And that's how we find the probability on the right hand side, by doing 1 minus what's on the left hand side. We only work with the left hand side because this is the side that the binomial CD in the calculator and in the table goes up to. It goes up from 0 successes up to and including the value that you have for x. So that's all fine for greater than and less than, and we've looked at less than or equal to. Let's take a look at the last one, which is probability of x equaling to 1. So what we're interested in here, it's, as you can see here, this is no longer an inequality, so we're not interested in a range of outcomes. We are simply interested in there being only one success. So how would that look like? Well, we can still work with our number line. There's our number line. Let's get rid of everything else. Things that... Okay. Now we're not interested in up to and including a number. We're simply interested in 1. So when we're only simply interested in 1, we are no longer doing binomial CD. It's the binomial PD, probability distribution, we can use. There's two ways you can do this, using the calculator, binomial PD, or you can do it manually. We look at both. So if you use the binomial PD, since it's only equaling to 1, we want only one success, we're only interested in that number, you would put that number, make sure your calculator is set on the binomial PD function when you go to the distributions. And again, choose variable, and it gives you the same kind of inputs, and for the input this time we're going to use x is equal to 1. This means it will only work out the probability at x equals to 1, not from 0 up to 1. It's no longer a cumulative, instead it's just a probability distribution at x equals 1. N is still 9, and probability of success is still 0.2. This then gives us an output of probability of x equaling to 1. No longer less than or equal to 1, it's just at 1 because we are considering binomial PD. So this gives us 0.3020 to 4 significant figures. So this is the way of using the binomial PD function on our calculator. Suppose we wanted to do this manually, because it's quite easily done, then we can say 9, choose 1, which is the number of ways we can be successful once from a list of 9 items, i.e. the number of ways you can pick one item from a list of 9. I.e. we can have success, failure, 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 1, 2, 3, 4, 5, 6, 7, 8, 9. We can have success once, failure 8 times, or you can have failure first and then success, and failure, 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 failure. So there's quite a few different combinations. How many different combinations are there? Well, we can arrange that in 9C1 different ways, the number of combinations. So this, if you did type into your calculator, will actually end up with 9 anyway. So let's see what this gives us then. So we're looking at 9C1 times, we want the probability of success, we want to be successful once, so probability of success is 0.2 to the power of 1, times we want failure, which is what's left over from 1, 1 take away 0.2 is 0.8, failure to come up 8 times. So you would type that into your calculator. 9C1, remember, is the different ways of arranging one item in a list of 9. Okay, so there are all the different combinations, ways of picking one item from list of 9. This tells us success once, and this tells us failure 8 times. Failure 8 times. Okay, and so this would then give us again the same answer, 0.3020. Type that into your calculator. Always remember to draw the number line at the beginning to decide what you are after.